Okay, so this is for College Algebra Math 13-14, Topic 1, Fraction and Proportions. So the concepts we're going to go through are adding, subtracting fractions with common denominators, adding and subtracting fractions with different denominators, multiplying fractions, dividing fractions, looking at some applications of fractions, and then defining ratios, and then applications of proportions. Remember, anytime you see applications, that means we are working on a real-world word problem. So the first concept, adding and subtracting fractions with common denominators. A over B is a fraction where A is the numerator and B is the denominator. If we have a common denominator, meaning that the denominators of both fractions are the same, then in order to solve, we add the numerators. So looking here at the formula, we have A over B plus C over B is equal to A plus C over B. Notice that in each of these fractions, they both have a common denominator of B. That's why we only add the numerators, that A plus C. So let's look at some examples. Example 1, we see that we have 7/8 minus 5/8. So they both have the common denominator of 8, meaning we're just going to subtract the numerators. So I have 7 minus 5 over 8. Simplifying this, 7 minus 5 is 2 over 8. And then notice that this 2 over 8 can be reduced even further, and that's what we're going to do. So both the 2 and the 8 are divisible by 2, so that reduces to 1/4, and this is our answer. Okay. Looking at number 2, again, we have a common denominator of 7. So I'm just going to add the numerators. So 4 plus 6 over 7 gives me 10 over 7. 10 over 7 is an improper fraction, but we're just going to leave it that way, okay? This cannot be reduced any further, so this is our answer. Okay. Notice in example 3, we have whole numbers attached to our fractions. So what we're going to do is we are going to take these proper fractions and we're going to turn them into improper fractions before we start solving. In order to do that, we're going to take that whole number and we are going to multiply it by the denominator. And then whatever answer we get here, we are going to add that to the numerator. And that is going to be our new numerator. So for example, 5 times 4 is 20. 20 plus 3 is 23. So this is now 23 over 4. So 5 3/4 is the same as saying 23 over 4. Okay, we're going to do the same thing for the next fraction. So multiply, then add. So 1 times 4, 4. 4 plus 1, 5. 5 over 4. Notice that we are subtracting these fractions. These fractions both have a common denominator of 4, so I'm just going to be subtracting the numerators. So 23 minus 5 over 4 is equal to 18 over 4. Notice that we can reduce both of these by 2, and we get 9 over 2, and that is our answer. Now looking at example 4, we're going to do the same thing. We see that that first fraction has a whole number on the outside. So we are going to turn this into an improper fraction before adding it to the 7/10. So 6 times 10 plus 1. That gives us 61 over 10 plus 7 over 10. Same denominator here, so we are just adding the numerators. 61 plus 7 over 10 is equal to 68 over 10. Okay, notice that we could simplify this by dividing both the top and the bottom by 2. and we would get 34 over 5. And that is our answer. Last example here, number 5. Again, we have two fractions that have whole numbers on the outside, so we're going to make them into improper fractions. So multiply, then add. Multiply, then add. So this first one, 3 times 4, 12. 12 plus 1, 13/4. Plus 1 times 4, 4. 4 plus 3, 7. 7/4. Okay. They have a common denominator of 4, so we are just adding the numerators. So I have 13 plus 7, which is 20. And I can reduce this 20 over 4 to 5. You could also say this is 5 over 1 and keeping it as a fraction. But just know that 5 over 1 is the same as just writing 5. Okay, let's look at the next concept. Adding and subtracting fractions with different denominators. If the denominators are different, then we first need to get a common denominator before we can solve. So in this formula, we have two fractions, a over b plus c over d, who have different denominators. In order to find a common denominator, the easiest way is just to multiply the denominators together. So that's what they did here. They had b times d, and then they used the corresponding denominator to multiply it by the opposite fraction. When they do that, they're going to get a common denominator, and then we just do the same as before and add the numerators together. So let's go ahead and see that example in number 6. So in number 6, we have 2/3 plus 5/6. So we have a denominator of 3 and a denominator of 6. Okay? Let's say we do not know how to find the common denominator between those two numbers. So we would multiply them. Okay? 3 times 6 is 18. So we would say that that is our common denominator. So now what we need to do is we need to multiply each fraction by what's going to make that denominator 18. So for 2/3, we would have to multiply the top and the bottom by 6. Okay. When we do that, we get 12 over 18. For the other fraction, the 5 over 6, we would have to multiply the top and the bottom by 3. So we're trying to get that common denominator of 18. When we do that, we get 15 over 18. So now if we were to add the numerators, we have 12 plus 15 over 18, which gives us 27 over 18. Notice that this can be reduced because 27 and 18 are both divisible by 9. So this gives us 3 over 2, and that's our answer. Okay. And again, this was us doing this in a way that we did not know how to find a lowest common denominator. You would want to find the lowest common denominator so when you get to the end, you are not simplifying as much. So we're going to see that in number 7. So in number 7, first thing we do is we're going to turn these into improper fractions. Okay? So remember, multiply, then add. So 4 times 7, 28. 28 plus 2, 30. So I have 30 over 7. Minus 1 times 14 is 14. 14 plus 9 is 23. So I have 23 over 14. Okay, now looking at these improper fractions, we notice that our denominators are different. We have a 7 and we have a 14. Okay. We could choose to multiply those together to get a common denominator, or we can notice that 7 and 14 are multiples of each other. Meaning if I multiplied that 7 by 2, I would get the common denominator of 14. So that's what I'm going to do. So I am going to multiply just this first fraction, top and bottom, by 2. That gives me 60 over 14 minus 23 over 14. Notice that my denominators are now the same, so I can just subtract the numerators. So 60 minus 23 over 14. 60 minus 23 is 37. Oops. Over 14. And that's our answer. Okay. Notice when we did this method, there wasn't really any simplifying that had to be done here, unlike number 6. Okay, so let's look at number 8. We have 8 over 10 minus 1 over 3. So finding the common denominator of 10 and 3, the easiest way here would just be to multiply, because I can't think of a multiple of 10 and a multiple of 3 that is the same and smaller than us just multiplying 10 and 3 together. So if I multiply 10 and 3 together, I'm going to have the new denominator of 30, meaning I'm going to have to take 8 over 10 and multiply top and bottom by 3. And then I'm going to take 1 over 3 and multiply top and bottom by 10. When I do that, I get 24 over 30 minus 10 over 30. Now that I have a common denominator of 30, I'm just going to subtract my numerators. 24 minus 10 over 30 gives us 14 over 30, which can reduce to 7 over 15. Okay. Looking at number 9, again, turning this into an improper fraction first. So we have 61 over 10, and then minus that 7 over 4. Okay. Here, I know that I could find the lowest common denominator between 10 and 4 to be 20. So in order to make each one have a 20 on the bottom, this first fraction, I'm going to multiply the top and bottom by 2, and the second fraction, top and bottom by 5. When I do that, I get 122 over 20 minus 35 over 20. Now I have a common denominator of 20, so I'm going to be subtracting the numerators. So 122 minus 35 is 87. So 122 minus 35 over 20 is equal to 87 over 20. And I'm just going to go ahead and say that is the simplest we can go. Okay, now let's look at number 10. Again, turning these into improper fractions first. So I have 16 over 5 plus 37 over 4. Okay. Here I need to find a common denominator between 5 and 4. And for this one, I believe the smallest we could get would be 20. So that would be multiplying 5 times 4. Meaning we would have to multiply the first fraction, top and bottom, by 4, so we can get 20 on the bottom. And the second fraction, top and bottom by 5, so again, we can get 20 on the denominator. When we do this, I have 4 times 16, which is 64, so 64 over 20, plus 37 times 5, which is 185 over 20. Adding the numerators together, 64 plus 185 gives us 249. Over 20. Let's see if we could reduce this any further. So 249 is odd, so we're not going to be able to divide it by 2. That's the same thing goes for 4. And then it doesn't end in a 0 or a 5, so can't divide by 5 or 10. So this looks like this is going to be the smallest we can get to. Okay. So moving on to the next concept, which is multiplying fractions. When multiplying fractions, we don't have to worry about the denominators. We just multiply the numerators together, then multiply the denominators together. So for our formula, we have two fractions, a over b times c over d. Notice that there is nothing that is the same here. We don't have any common denominators, anything like that. Because all we're doing is we're multiplying the tops across, and then we're multiplying the bottoms across. So in this formula, that gives us a times c over b times d. So let's look at some examples here. So again, we're multiplying. So I'm going to multiply the top across. 2 times 5 gives me 10. And then I'm going to multiply the bottoms across. 3 times 6 gives me 18. I can reduce this by dividing both the top and bottom by 2. So 10 over 18 turns into 9 over 2. Okay. Same thing goes for the rest of these examples, but again, before we can do anything, we have to turn these into improper fractions. So we're going to go ahead and do that first, turn them into improper fractions. So this first one, we have 30 over 7 times, let's see, that's 10, 19 over 10. So if I just multiply these across, 30 times 19 gives us 570. 7 times 10 gives us 70. Right away, I know that I can reduce this quickly because they both end in 0. So those zeros cancel, and I'm left with 57 over 7, which is my answer. Okay. When I canceled those zeros out, that's the same as me saying I'm dividing the top and bottom by 10 to reduce it. Okay, number 13. So we don't got to turn anything to an improper fraction here. We are just multiplying across. So in the first one, we have 8 times 1, which is 8. 10 times 3, which is 30. Notice that both the 8 and 30 are divisible by 2. So that gives us 4 over 15. Okay, and that's our answer. Number 14, we're going to have to turn that first fraction into an improper fraction, and that gives us 61 over 10 times 7 over 4. Multiplying across, we get 61 times 7, 427. So 427, and 10 times 4, which is 40. And then again here, I'm not sure if this could be simplified any further. So I'm going to go ahead and just say this is my answer. Okay, and then lastly on 15, We don't have anything to turn into an improper fraction. Notice that that second fraction is already improper. So we have 1/5 times 11/4. Again, we're just multiplying across. 1 times 11 is 11. 5 times 4 is 20. 11 over 20 cannot be reduced, so this is our answer. Okay, next concept, dividing fractions. When dividing fractions, we first have to take the reciprocal of the second fraction. Once you take the reciprocal, you change the division sign into a multiplication sign and multiply across. So when we see the word reciprocal, just know that that means to flip the fraction. So right here, this word reciprocal just means to flip. Okay. Looking at the formula, we have two fractions, a over b and c over d, that are dividing by each other. Notice all they did with that second fraction is that they flipped it. So instead of c over d, it is now d over c. And that multiplication sign got changed from the division sign. And then you just multiply across. So that's what we're going to do first. First thing is flipping this fraction. So we have 2/3 times 6/5 because I flipped 5 over 6 to be 6 over 5. And then I multiply across. 2 times 6 is 12. 3 times 5 is 15. 12 and 15 are both divisible by 3, so I get 4 over 5, and that is my answer. Okay. Same thing for 17. The first thing we're doing is we are flipping that second fraction. So I have 2 over 7 times, because I'm changing my division to a multiplication, 10 over 9, because 9 over 10, when we take the reciprocal, is 10 over 9. Multiplying across, I have 2 times 10, which is 20, and 7 times 9, which is 63. And let's see here, I'm sure, yep, this is the furthest it can be simplified, so 20 over 63 is our answer. Okay, again with 18, we take our second fraction, which is 1/3, and we are going to flip it. So 8 over 10 times 3 over 1. So remember, if we see a number over 1, that tells us that we could rewrite this as just a whole number 3. But since we are dealing with fractions and multiplication, it's easier to visualize this by leaving it in a fraction. So we're still multiplying the tops and then multiplying the bottoms. So 8 times 3 is 24. 10 times 1 is 10. 24 and 10 are both divisible by 2, and we get 12 over 5, and that is our answer. Okay. Same thing with 19. We are going to take our second fraction and flip it. So we have 6 over 10 times 4 over 7. Multiplying the top, 6 times 4 is 24. The bottoms, 10 times 7 is 70. And I believe that is as simplified as it gets as well. So 24 over 70. Okay. Last example for this concept. Again, we are taking that last fraction. In this case is 11 over 4, and we're going to flip it. So we have 1 over 5 times 4 over 11. Multiplying across, 1 times 4 is 4. 5 times 11 is 55. And this is our answer, 4 over 55. Okay, so that goes over all of the properties of fractions, adding, subtracting, multiplying, dividing. Now we're going to use those skills in the next concept when we're talking about applications of fractions. So when you see the word applications, this simply translates to a real-world problem, otherwise known as a word problem. So in these examples, we are going to figure out if we're going to be adding, subtracting, dividing, or multiplying these fractions, and then we're going to go ahead and solve. So in the first example, it says Dolores sold candy by the pound. The first person who came into her store bought 2 1/4 pounds of gumdrops, and the second person who came in the store bought 5 3/4 pounds of jelly beans. How many pounds of candy did Dolores sell to her first 2 customers? So since it wants to find the total, that tells us we are adding these fractions together. So I have 2 1/4 plus 5 3/4. Okay? So the first thing I need to do here is I need to turn these into improper fractions. So doing that, this turns into, let's see, 9/4 plus 23/4. Okay. Notice that these have common denominators of 4, so we're just adding the numerators. 9 plus 23 is 32. So 32/4. This reduces to 8. So this 8 is our answer. But since we're dealing with a word problem, we're going to have to write a sentence explaining the answer. So the question was, how many pounds of candy did Dolores sell to her first 2 customers? So we're going to write, she sold 8 pounds of candy. Technically, this right here is our answer. Okay, so if you are solving a word problem, your answer should be in the form of a sentence. Okay. Okay, number 22, we have in language arts, the class was assigned to write a term paper. Each team was to write 5.5 pages for the combined paper. When all the teams put their papers together, there was a total of 44 pages. How many teams had worked on this paper? So here we're dividing. So we have 44 divided by 5.5. Okay. So first, I'm going to turn this second fraction into an improper fraction. So in doing this, I have 44 divided by 11/2. Since I'm dealing with fractions, I want to turn that 44 into a fraction. So I'm just going to write it over 1. So now I have 44/1 divided by 11/2. Remember, when we're dividing, we take that second fraction, flip it, and then multiply. So I have 44/1 times 2/11. When I multiply across, I get 88/11, which simplifies to 8. So remember, even though that is my numerical answer, I still need to write a sentence to solve this word problem. So the question was, how many teams had worked on this paper? 8 teams worked on this paper. This is my answer. Okay. Number 23 says Dennis's new dog weighs 127 3/4 pounds. Okay, so here's one key information. His friend's dog weighs 94.5 pounds. How much more does Dennis' dogs weigh than his friends? So here we want to find the difference, which meaning we are subtracting these two fractions. So 127 3/4 minus 94 1/2. First thing we got to do is turn these into improper fractions. So I'm going to take 127 times 4 and add 3. Oops. That gets me 511. So this is 511 over 4 minus, now I'm doing 94 times 2 and adding 1. So that gives me 189 over 2. Notice that my denominators are different. So I have a denominator of 4 and a denominator of 2. I want them to have the same denominator. So what I could do is I can multiply that second fraction, top and bottom, by 2. And then that way I would have both the same denominators of 4. So that's what I'm going to do. Multiply this one, top and bottom, by 2. So that leaves me with 511 over 4 minus, so 189 times 2 is 378 over 4. And now if I subtract that, I get 133 over 4. Okay. Let's go ahead and change that into a decimal by putting on our calculator 133 divided by 4. This gives us 33.25. Okay. So either one is correct. Since I am dealing with the word problem, having that whole number of 33 is helpful. Remember, I need to answer my question, and my question was, how much more does Dennis' dogs weigh than his friends? So we are going to write that his dog weighs 33.25 pounds more. And that is our answer. Okay, number 24. On their vacation trip last summer, the Pace family got 30.5 miles per gallon of fuel on their trip from home. On the return trip, they only got 17 7/8 miles per gallon. How many more miles per gallon of fuel did they get on their way out than on their way home? So again, this is another subtraction. So we are taking 30 1/2 minus 17 7/8. Okay. Turning these into improper fractions, we get 61 over 2 minus, so I have to do 17 times 8 plus 7, 143 over 8. Okay, again, notice that these do not have a common denominator. So we need to find a common denominator between 2 and 8. In this case, it would be 8, meaning we would only have to multiply the first fraction, top and bottom, by 4. When we do that, 61 times 4 is 244 over 8 minus 143 over 8. Subtracting these two numerators, now that we have a common denominator, we get 101 over 8. And I'm going to go ahead and just see what that is in decimal form. So that is 12.625. So writing a sentence and answering the questions, how many more miles per gallon of fuel did they get? They got 12.625 more miles per gallon. That is our answer. Okay, last application, number 25. says Joy and her friend wanted to do something different. They decided to go to the track and see how many times they could run around the track without stopping. When they finally finished, their stopwatch showed they each ran a total of 23 2/5 minutes. If on average Joy also knew it took them 4.5 minutes to run the track once, how many times did they run around the track? So in this one, we have to take that 23 2/5 and divide by that 4.5. So 23 2/5 divided by 4.5. Got to turn these into improper fractions before we start. 23 times 5 plus 2, that's 117 over 5 divided by 9 over 2. So this gives us 117 over 5 times 2 over 9. Got to flip that second fraction. And then multiplying across, we get 117. Let's see, 117 times 2, which is 234. And 5 times 9, which is 45. I'm going to go ahead and make that into a decimal. And I get 5.2. But remember, I got to write this in a sentence. So the question was, how many times did they make it around the track? So I'm going to write, they ran about 5 laps around the track. This is my answer. Okay. So that concludes everything about fractions. Now we're going to look at defining ratios. So a ratio is another word for a fraction. It is a number in the form A over B, where A is the part and B is the whole. So the formula for this, instead of saying A over B, we would say part over whole. So in these examples, it wants you to write a ratio to represent the shaded section of each diagram. So doing this, we're going to count the shaded parts, and then we're going to write that over the whole, the number of total parts. So in this one, we have 3 shaded parts over 8 whole parts, meaning our ratio here is 3/8. Okay. For this one, we have 6 parts over 8 wholes. This could be reduced to 3 over 4. So that is our answer. The ratio for this shaded region is 3/4. Same with 28, 29. We are looking at the shaded region. So for 28, we have 2 shaded regions, and there are total of 3 blocks there. So our ratio is 2/3. For 29, we have 3 shaded, but 4 total. So part over whole, our ratio is 3/4. Number 30, notice that we have 2 objects here. We have one of the objects that are completely shaded in, and then another object that only has 2 parts shaded in from the whole. So let's go ahead and treat these as 2 separate fractions, 2 separate ratios. So for the first one, we see that 3 is shaded over 3 whole. And then for the next part that we're going to add to our first shaded region, we have 2 shaded over 3 whole. Okay, since we have common denominators here, we could just add the tops. 3 plus 2 is 5. 5 over 3 would be our answer. Or you could choose to acknowledge that this first one, since it is completely filled in, could just be written as the whole number 1. And then this one, since it is only 2/3 filled in, this would be 2/3. So this could be written as 1 2/3 or 5/3. Both are correct. For the next part, we are going to identify in these real world problems, what is the part, what is the whole, and we're going to write it as a ratio. One moment. Okay, so for 31, it says Taylor tipped $8 on a 25.58 bill. So part versus whole. So $8 is part of what they're going to pay. 25.58 is the whole of their bill. So if we were to write this as a ratio, this would be 8 over 25.58. And let's go ahead and just simplify that on our calculator. Type exactly 8 divided by 25.58. That gives us approximately 0.31. Okay. This tells us if we were to turn it into a percent that this person tipped 31% of his total bill. Okay, same thing with 32. It says in a 82-game regular season, the Spurs won 68 games. So it says 82 games in a season. This is the whole, because it's the total amount. And 68 games won. So this is the part. So this would be 68 over 82. Let's go ahead and type that and see what that decimal is. So 68 divided by 82, we get approximately 0.83, so 0.83, which tells us that out of all the games total, the Spurs won about 83% of them. Okay. Number 33 says Stacy has caught 272 out of the 802 Pokemon. So 272 is our part, 802 is our whole, which means we write this as a ratio 272 over 802. Turning that into a decimal on our calculator, we get 272 divided by 802, which is approximately 0.34, so 0.34, which tells us that Stacy has caught about 34% of the total amount of Pokemon. Number 34 says my paycheck is $950, but $154 was taken out for taxes. So the total paycheck, $950, is our whole. The $154 is the taxes taking out, so that's part of our paycheck. So we have $154 over $950, that is our ratio. Turning our ratio into a decimal, we get 154 divided by 950, and we get approximately 0.16, which tells us that the taxes taken out of the paycheck was about 16%. Okay, lastly, it says, I am on a 5 3/4 hour road trip. So far, I have driven 2.5 hours. So the 5 3/4 is the whole. 2.5 hours is the part. So we write our ratio as part over whole. So 2.5 over 5 3/4. Okay. Notice that when I write this fraction bar can be written as a division sign. So what it wants us to do here is take these two fractions and divide them. So I have 2 1/2 divided by 5 3/4. First, got to turn them into improper fractions. So I get 5/2 divided by 23/4. I have to flip that second fraction, so I have 5/2 times 4/23. And this gives me 20/46. That is my ratio, so 20/46. Put that into my calculator, and I get approximately 0.43. So this tells us that so far, she has driven about 43% of her total trip. Okay. So this was the concept of defining ratios. So ratios are the same thing as fractions. Last concept here, we have the applications of proportions. A proportion is an equation of the form ratio equals ratio. It is defined as A over B is equal to C over D. Okay. When we are dealing with applications of proportion, so a ratio equal to another ratio, typically what we need to do is there is an amount in there that we need to find. So in the first two examples, in 36 and 37, the amount that we need to find is defined by x. So we need to get x by itself. When you have a ratio equal to another ratio, in order to solve, we are going to cross multiply. So what I mean by cross multiply is that in number 36, we're going to have 30 times 3.4, and then x times 5. Okay, so first 30 times 3.4, we're going to write that equal sign, 5 times x. So this is our yellow, then the pink. Okay. Once we cross multiply, instead of having a ratio equal to a ratio, we just have a simple linear function. Okay. Meaning it is easy for us to get x by itself. So for this case, 30 times 3.4 is 102. Make sure I wrote that right. Yep, 102 is equal to 5x. X times 5, we write that as 5x, always the number in front of the variable. So in order to get x by itself, we're going to divide both sides by 5, and I get x is equal to 102 divided by 5, which is 20.4. That is our answer. Noticing that these first few applications, it doesn't have a question that it is asking us, so we do not have to write a sentence here. Okay, so same thing for 34. We have a ratio equal to another ratio, which means we cross multiply. So we are going to do 25.8 times 1 and 8.6 times x. So I have 8.6x is equal to 25.8 times 1, which stays the same. That's why I'm not going to write that times 1. Notice that it doesn't matter which order I did it. On the first one, I had the process of my x ending up on the right side. And on 37, my x ended up on the left side. Doesn't matter which side that you are writing it on because these two sides are equal to each other. So in order to get x by itself, I'm going to divide both sides by that 8.6. And I get x is equal to 25.8 divided by 8.6. And I get 3. Now looking at some actual word problems on number 38, it says after college, Sally starts a job earning $21,500 a year. Every month she saves $500. How many years would it take for Sally to save $20,000? So again, we need to set up a ratio equal to a ratio, okay? Our missing information here is how many years. So that is going to be our variable. So I'm going to go ahead and label years as Y. Okay. So she wants to find out how many years to save 20,000. So how many years to save 20,000, that's one of her ratios, is going to be equal to how much she saves every month. So she saves $500 a month, but since our answer is going to be in years, I'm going to go ahead and times that 500 by 12. And then write that over the total, the 21,500. Notice that each of my ratios is a part over a whole. So how many years that she is going to be able to save 20,000, how much she's saving versus how much she's making. Notice that every single aspect is in terms of years. Okay, if I did not multiply that 500 by 12, that 500 would be invalid because that's how much she saves a month, not how much she saves a year. Okay, once I have everything set up, I'm going to cross multiply. So Y times 21,500 and 20,000 times 500 times 12. So I have 21,500Y is equal to 20,000 times 500 times 12. Running out of room there. I'm going to go ahead and multiply that 20,000 by 500 by 12. So 20,000 times 500 times 12. Okay. That gives us 120 million. So 21,500Y is equal to 120 million. I'm going to divide both sides by that 21,500. And I get Y is equal to approximately 5,581 years. Let me make sure I set that up right. Seems like a long time to save 20K. But yes, that was how long it would take to save that 20,000. I know it looks very crazy, the amount, but these are make-believe problems. If you make, for 39, if you make 9,800 in 3 months, how much do you earn in 1 year? So 9,800 in 3 months, how much would you earn in 1 year? But since everything is in months, I'm going to say 12 months because that's equivalent to 1 year. Cross multiply. And I have 9,800 times 12 is equal to 3x. 9,800 times 12 is 117,600 is equal to 3x. Divide both sides by 3 and we get x is equal to 39,200. And x was in term of, yep, so how much do you earn in a year? The total amount you would earn in a year is a little more than 39,000. That concludes the notes for topic 1, fractions and proportions. And let me know if you have any questions.